After studying this module, you shall be able to understand the merits of factor analysis, know the major limitations of factor analysis, learn the application of factor analysis in the areas of social life, know a demonstration of the factor analytic study of socio-economic status, frustration and anxiety. The purpose of factor analysis is to identify salient features that account for the majority of the variance of a group of scores on different tests. Factor analysis helps in the reduction of variables by combining two or more variables into a single factor. It also identifies groups of interrelated variables to see how they are related to each other. Contrary to this, the interpretation of factor analysis is based on using a heuristic, and hence one interpretation can be made of the same data factored the same way. This results in a failure of identifying causality. Hence, this module focuses on the merits and limitations of factor analysis. Charles Spearman pioneered the use of factor analysis in the field of psychology and is sometimes credited with the invention of factor analysis. Cattell expanded on Spearman's idea of a two-factor theory of intelligence after performing his own tests and factor analysis. Though psychology is most often associated with intelligence research, it has also been used to find factors in a broad range of domains such as personality, attitudes, beliefs, etc. It is linked to psychometrics as it can assess the validity of an instrument by finding if the instrument indeed measures the postulated factors. Hence, in the following module, we will also look at the applications of the findings of factor analysis in varied fields of social life. Merits of factor analysis. Factor analysis serves various purposes which include determining how many latent variables underlie a set of items, condensing information so as to account for variation, defining the substantive content or meaning of factors, and identifying items that are performing better or worse. The main merits of factor analysis can be stated thus. The technique is helpful in pointing out important and interesting relationships among observed data that were there at that time but not easy to see from data alone. The technique can reveal the latent factors, that is, underlying factors not directly observed, that determine relationships among several variables concerning a research study. For example, if people are asked to rate different chocolates like Dairy Milk, Munch, Perk and so on according to preference, a factor analysis may reveal some salient characteristics of chocolates that underlie the relative preferences. The technique may be used in the context of empirical clustering of products. Major limitations of factor analysis. Apart from considering its merits, one should also be aware of several limitations of factor analysis. Some of the important ones are: first, factor analysis, like all multivariate techniques, involve laborious computations involving heavy cost burden. With computer facility available these days, there is no doubt that factor analysis has become relatively faster and easier, but the cost factor continues to be the same. That is, large factor analysis are still bound to be quite expensive. The results of a single factor analysis are considered generally less reliable and dependable, for very often a factor analysis starts with a set of imperfect data. The factors are merely blurred averages, difficult to be identified. To overcome this difficulty, it has been realized that analysis, our confidences concerning such results, increases. Factor analysis is a complicated decision tool that can be used only when one has thorough knowledge and enough experience of handling this tool. Even then, at times, it may not work well and may disappoint the user. To conclude, we can state that in spite of all the said limitations, factor analysis not only helps the investigator make sense of intertwined data, but also points out some interesting relationships that may not be obvious from a more superficial examination. Applications of factor analysis. Factor analysis is a popular area in psychometry, and many of its principles find application in theory development as well as in solving problems concerning common social life. Some of the areas wherein factor analysis finds important applications are discussed. First, theory development. Several theories of intelligence have been based on the application of factor analysis. Important among these are Spearman's two-factor theory, Thurston's theory of primary mental abilities, Guilford's structure of intellect model, Cattell's theory of fluid and crystallized intelligence, and Vernon's hierarchical theory. Other non-factor theorists, namely Weismann, Hayes, and Ferguson, have also emphasized the importance of learning in the determination of human abilities. Developmental theories of cognition as proposed by Piaget stress the concept of stages and organism-environment interactions in the formulation of intellectual abilities. Second, test development. Another important area in which factor analysis has been used is the development of tests. In this aspect, factor analysis helps in deciding the factor structure of the items in a test and also in giving the name to the concept to be measured by the test. Factor analysis has also been found to be useful in the search for primary interests, attitudes, and temperament traits. By 1947, the US Army and Air Force had reported some 4 years of wartime research on test development in which factor analysis played a key role. The phenomenal properties of sensory response have been verified by 2 or 3 studies. Third, applications in vocational psychology. An important field directly susceptible to the application of factor analysis is that of vocational psychology. In the area of personnel selection, factor analysis has been used very successfully. In vocational guidance, much emphasis is placed on personality profiles. A personality profile is difficult to interpret unless the nature of the scores that go into it is known. The best way of knowing the nature of the score is to have it factor analyzed. Applications in personnel selection and job performance. In selection of personnel for certain assignments, we obtain the greatest efficiency of selection if the test or test battery we use measures all the significant common factors involved in the success on the job. There will come a time when job assignments will be specified in terms of weightage combination of the factors. When the combinations are known, we can write the prescription for successful tests to use in selecting personnel. When tests prove valid for a certain selection purpose, the explanation is in terms of the common factors that are related both to the tests and to success on the job. A battery of factorial tests achieves great economy of testing effort. There needs to be a maximum of only one test per common factor involved. Many present batteries composed of many tests may be wasteful in that they measure over and over again the same factors, limited in number. In the classification of personnel, univocal factor tests definitely come into their own. In selection, we can tolerate 2 or more common factors per test, provided all are also related to the job criterion and all are weighted to advantage. In classification, we sort persons among jobs so that differential prediction becomes very important. If we are to say that person A should be assigned to job X in preference to Y or Z, or if we are to say that of 2 persons A and B, the assignment to job X and Z respectively and not the reverse, we must be able to discriminate as much as possible the patterns of abilities of A and B. We are concerned with differences in job patterns and individuals' pattern of traits rather than in amounts of ability in each factor as such. We cannot establish patterns and differences in relatively unique variables without having separate measures of the factors. Applications in clinical psychology. Clinical psychology generally would find the concepts developed by factor analysis very useful, where they have been tried, and this is unfortunately on very rare occasions, they have proved to be understandable, communicable, and dependable. There is little more than one could ask of a concept. What is more, the factor concept has reference, a fact which passes the hurdles of semantic and operational standards. As Cattell has pointed out, the most important step in mastering problems of personality is to have a good list of descriptive items. Applications in experimental psychology. Experimental psychology has more problems involving unknown variables than it realizes. Its superficial justification of this remark is the fact that most of its measurements are of the nature of test scores. Studies of learning, memory, motivation, and thinking commonly utilize measurements that belong in the category of test scores. The scores are likely to be factorially complex as those of vocational psychology. The underlying psychological variables are usually assumed, but actually they are usually unknown. There is much that one could with experimental variables in the way of framing laws on that same level. In terms of more fundamental theory and systematic ramifications, however, it is likely that much is missed. Let us understand an illustration of a factor analytic study of socio-economic status, frustration, and anxiety. Studies have shown that frustration exerts three effects on the behavior of an organism, which are inhabitation, that is avoidance responses aroused by conditioned frustration counteracts approach responses. Second, excitatory, that is vigorous responses following the arousal of frustration. And third, reinforcing, which is learning of responses allowing escape from frustration arousing stimuli. The circumstances and situations that are potentially capable of preventing immediate and direct satisfaction of our needs and thus leading to frustration are numerous. Man's physical and social environment, individual limitation, and psychological complexities are the main block causing frustration. Keeping these in view, a factorial study was done by taking into consideration the socioeconomic status, frustration, and anxiety of the subjects. Methodology. The sample consists of 100 students of grade 10th of a government school situated in New Delhi. The procedure for selection of the school was random and the sample could be regarded as a systematic random sample. These 100 students were assessed on socioeconomic status, frustration, and anxiety. The tools employed for measuring socioeconomic status, frustration, and anxiety, 3 tests were administered, which were Kulshrestha Socioeconomic Status Scale, Chauhan and Tiwari's Frustration Test, and Sinha's Comprehensive Anxiety Scale. The selection of these tests was done on the basis of high reliability and validity of these tests. Procedure. Rapport was established with the students by explaining to them the objectives of the study in brief. The data was collected by administering the tests to a group of 20 to 25 students in different settings and on different days. The scoring of each scale was done as per the manual instruction. The Kulshrestha scale measures socioeconomic status, the Chauhan and Tiwari scale measures regression fixation, resignation, aggression and frustration, and the Sinha test measures anxiety. Thus, altogether 7 variables were scored and subjected to analysis. Results, interpretation and discussion. Before the factor analysis was carried out, the product moment coefficients of correlation for all the 7 variables were computed and displayed in a 7 by 7 matrix. The 7 variables were socioeconomics, regression on fixation, resignation, aggression, frustration and anxiety. The correlation values are 1 minus 0.63, which was a significant value, minus 0.67, a significant value, minus 0.62, a significant value, minus 0.62, a significant value, minus 0.66, a significant value, and minus 0.28. For regression, 1.0, 0.88, 0.88, 0.77, 0.82 and 0.48, all significant values. For fixation, 1, 0.79, 0.78, 0.98 and 0.67, again significant values. For resignation, 1, 0.83, 0.93 and 0.44, significant values. Aggression, 1, 0.92 and 0.45. Frustration, 1 and 0.62, and anxiety, 1. The data was subjected to factor analysis to study the structure of variables. The program used for the factor analysis was based on Pearson product moment correlation and subsequently on principal component solution with eigenvalue 1 as the cutting point to retain the factors. Following the process of principal component solution, only one factor was extracted from the 7 variables analyzed. It was thought inappropriate to carry out varimax rotation as only one factor was extracted. The significance of factor loadings was tested by using table B of Herman, where the standard errors of the factor coefficients are given. In practice, the standard error of the factor loadings were multiplied by p is equal to 0.01 value of t with appropriate degrees of freedom. When this value was less than a particular factor loading, the loading was accepted to be significant. The other procedure adopted was that the loadings were accepted as a significant if their values were greater than 0.30. Both the methods in fact yielded the same results. In this particular study, the second method was employed. The factor loadings for the unrotated factor matrix were given as minus 0.73 for the socioeconomic variable, 0.92 for regression, 0.93 for fixation, 0.91 for resignation, 0.91 for aggression, 0.99 for frustration and 0.60 for anxiety. While interpreting and naming the factors, greater weightage was given to high loading variables. The factor was found to contain significant loadings on all the 7 variables, namely socioeconomic, regression, fixation, resignation, aggression, variable, and frustration and anxiety. Except for the socioeconomic status, all other variables showed positive and significant loadings on the factor extracted. Out of 6 variables, 5 belong to frustration and the 6th belongs to anxiety. This suggests that frustration and anxiety are highly correlated. On the other hand, socioeconomic status contains a negative and significant loading on the factor extracted. This implies that socioeconomic status is negatively related with frustration and anxiety, that is, poor socioeconomic status will lead to high frustration and anxiety. One can say that the reason for high degree of frustration and anxiety is the low socioeconomic status. In another sense, persons with low socioeconomic status are more frustrated and have higher anxiety levels. Keeping in view the above loadings, this factor may be named as socioeconomic status and factor for frustration and anxiety. This revealed that for an individual to be frustrated, a variety of factors rather than a unitary factor are needed. The study also showed negative relationship between socioeconomic status and all its components of frustration, namely regression, fixation, resignation, aggression and frustration. There is a positive and significant relationship between anxiety and components of frustration, that is regression, fixation, resignation, and aggression. Anxiety may be defined as a mental distress with respect to some anticipated frustration. Sometimes, trivial matters and minor frustration cause a feeling of uneasiness. Growing out of many frustrating situations, anxiety serves as the driving force for a large number of subsequent adjustments. This anxiety has its origin in birth trauma. It arises more out of loss of love rather than lack of love. This could be one of the reasons for a positive and significant correlation between anxiety and frustration. Note that P is the level of significance and T is the student distribution. Summary. Factor analysis helps in the reduction of variables by combining two or more variables into a single factor. It also identifies groups of interrelated variables to see how they are related to each other. Factor analysis serves various purposes, which include determining how many latent variables underlie a set of items, condensing information so as to account for variation, defining the substantive content or meaning of factors, and identifying items that are performing better or worse. The interpretation of factor analysis is based on using a heuristic, and hence one interpretation can be made of the same data factored the same way, serving as a disadvantage of this technique. Factor analysis has found its use and application not only in the field of intelligence research but also in domains such as personality, attitude, beliefs, etc. It is linked to psychometrics as it can assess the validity of an instrument by finding if the instrument indeed measures the postulated factors.